Thank you. Do we have sound? Yeah. Cool. So welcome everyone to this talk on automated testing with Umbraco. And pretty much any software you build. We're going to go through quite a few tools and techniques to get a grip on this technique and make it work for you. So, first of all, I'll give you a little bit background about who I am. My name is Lars-Erik Aabech. I've been a professional web dev since '98, so I'm going on my third decade. That's kind of scary. I've been at my current company for 17 years. Really nice place to work, and I get to decide how I work, so that's how I got into unit testing. I could just trump it through, so I really recommend that. We've been Umbracians since 2012, and we're really, really happy about that choice. Previously, we had our own CMS, and that's kind of a pain to maintain in the long run if you also do agency work. I'm a bona fide version 5 certified developer. Quite proud of that. But I've also managed to get my version 7 master since, so hopefully soon there'll be a version 8 degree out as well. I've been lucky enough to be awarded MVP 3 times now, so I'm pretty proud about that, and I think that's because I'm an avid fan of solid principles and automated testing, which is why we're here today. So enough about that. I've been talking with a lot of people during this week, and quite a few are still not unit testing, and why is that, is the first question I want to address today. And the main reasoning people come around with is that we don't have time. There's no time in the budget. There's no money to put testing in there. And I pretty much completely disagree with that statement, because it's not something that the customer should pay for. It's something that we should just do. But I recognize and I appreciate the fact that it's kind of hard to get started and hard to kind of feel that you actually have the time to do this stuff. So I want to go through what we usually do if we don't unit test and we just sit down and do some software. And what happens then is that we do what every developer do, we make some code, right? And no matter what we do, we also have to build that code, and that build process takes a little while. Especially if you're going to build your whole solution. If you can build a few projects, then it goes faster. When you build the whole solution every time, it takes quite a while to build it. Subsequently, we start up a web server, of course, we start a browser, and then we have to wait for some runtime compilation and warm-up stuff on iOS, and things take a bit more time before we can actually start clicking around our solution. And when we start to click around our solution, we actually spend more time just setting stuff up for what we're actually gonna test. And then finally, when we're there at the target thing we're going to investigate, we can verify that it all went well, because it always goes well, right? We only write clean, pure, working code every time, and we can go back coding. Anybody recognize this kind of loop? Yeah? It's only part of the picture, though, because the minute we didn't write the perfect code at first, this happens. Right? How much time do you spend in there? And by the way, this takes a way longer because we're going to load debug symbols in addition to warming up the site, right? So this is the cycle you're in. Every day you're not testing. And I dare to say that this actually takes way more time. You're going to spend like half an hour every day just waiting for this process and clicking around. So the solution is do automated testing. So then you're going to come into this cycle where you do some code. And you build, of course, and the build is fairly much the same time, unless you actually test fewer projects at a time. Then you can build fewer projects. And the magical thing about tests is that they run, you don't have to do anything. And even more magic, they verify everything for you. And then you can go back to code. Oops. Anyway, that's a partial picture as well, though. Because we code, we build, we run tests, we automatically verify, but stuff still breaks, right? We're still not perfect, so we do debug. But we're in a way more focused state, and we've pinned down the feature that isn't working, and we can jump straight into the debugger. We can get there immediately without clicking around, and we can just fix up that little bit that just failed. Then we can go back and write more code and stay in a way smaller cycle that takes way shorter time every time. So we're already saving like half an hour every day, not waiting for this whole other process, right? So what I think everybody's actually saying is we don't have the time to learn how to unit test, and that's a completely different matter than we don't have the time to unit test. If you try to start learning, you're probably going to have to invest some internal time, some non-billable hours for 1 or 2 projects, but then you're going to start getting the hang of this shit, and you can work faster on the subsequent projects without actually changing the budget. That's something to think about. Because when we do testing, it feels like it takes more time, so we have way more setup time over here. But when we've done it, and we've got this little nice test framework, and we can add more tests continuously, and they all keep working, that time is going to flatten out, and you're going to produce predictable features every day. And you know all the time that your software worked like 5–10 minutes ago, so you can just roll back 5 minutes and start over, and you're going to produce. If you don't do this, well, one of the things that is an effect of testing is that your code is going to get cleaner and more loose coupled as well, which might be way harder to do if you're not doing testing, because you don't have to mind it that much. It's a requirement for testing, but it's not a requirement for production code. So it's fairly fast to get into a messy code base as well. And what happens is that you feel you're going really, really fast for a while, but get to production, and bugs start popping up in production, and you have to fire up the debugger, and you sit there and scratch your head for 2 days, and you can't really deliver more features, because things keep blowing up all over when you add more features, because you have no idea what you're changing. And that's what testing brings. It gives you a flat line of production predictability, which I haven't really experienced in other kinds of projects. So that really means we don't have the time to learn to do our job properly, instead of we don't have the time to learn how to do unit testing, in my opinion. And the really, really dangerous thing is to find between the lines here that we're actually saying we don't want to learn how to do our job properly at all. But you are all here, so I imagine you have already disposed of that statement, so we can go on and look at how we can do this well in a predictable manner. So to explain a few scenarios here and a bit of the history of unit testing, I've made a little example of a recently used list. It's kind of what pops down in your browser when you start typing there. It remembers where you were last. And you can kind of set it to a size. And the point is the last one to go in is on the top, so it's the first one you find on the top. But if it was already there in the list, it's just moved to the top. When I started learning programming back in the 90s, I had this snail mail course in Pascal. And one of the things in that book that I had for that course was something called drivers. And this is a really old concept. You want to make throwaway applications that test this and that function in a quick way, so you don't have to go through menus and wade through screens to get to your function. You just write something that drives this specific little function. We could do web pages with buttons to click to invoke those functions, some other UI. We could use Windows, VB6 back in those days. But I haven't, all the examples are in C#, just imagine they are VB6 or something oldish. Or we could, of course, flush out big log files that we had to parse manually or make reports from or whatnot. And it could look kind of like this. So we have a little application where we feed stuff into that list, and we print them out on the screen, and it's going to look kind of like this. But I still have to kind of type stuff in there and parse the list in my head and verify, yeah, this is still right. But it's a bit quicker than actually going into the full application. But it still takes a bit of time. We could also do it with Windows Forms, back then VB, of course. And it would look kind of like this. Here we could have several buttons and bells and whistles and whatnot, and we could test kind of more features in the same window, or yeah, basically make fast ways to get into the function you want to work with. But it still takes quite a lot of time, and it takes time to manually verify all this stuff. Around comes the millennial shift, and Martin Fowler publishes a great book called Refactoring. The second edition just arrived with JavaScript refactoring. I really recommend to read both books, actually, because it's two different paradigms. And he calls it self-testing code and wants us to have something that automatically verifies that the code is right, so you don't have to go through all those manual processes of verifying everything. It could look kind of like this, the same console application that I just showed you, except that on the top we have this little expected list, which is kind of an expectation of how the output is going to be. And then you can do the same things, you can add a few things. But finally, the difference from verifying manually is that you actually code in the verification here. And if they aren't equal, you throw an exception instead. This is going to look like this. And that's going to be a bit quicker than actually having to verify everything yourself. So not that bad time-wise. But a couple of years later, Kent Beck publishes a book called Test-Driven Development by Example, which is another great book where he goes through a domain object for money and actually explores several different architectures for that without actually changing the behavior. And it goes through how you can add automated tests that verify all of this. And with it, he brings a mindset for developing and actually driving the design of your code, which is way more than we had with drivers and self-testing code as something just to verify that you don't have bugs. And the magic thing about them is that they verify their own results by calling some sort of assertion, is the terminology there. And what you end up with is a huge set of classes and methods that are designed to run in unordered sequences. So everything is supposed to be in isolation, just like we did with the drivers. But the magic thing is that they are automated. You don't have to click around the application. You don't have to parse anything manually. It just goes by itself. And you end up with a comprehensive list of statements about your software and results for all those statements. And again, you don't have to parse that. So here's an example of how that could look for my recently used list. So on top you have a wee little setup where you say that I'm going to use a list with 10 items in them. And initially it's empty. When you add something to it, it's going to be on the top. When you add two things, the last thing you entered is going to be on the top. And finally, we can test with more things, and we can just go on and on and on, stating things about our software, and finally getting a check mark for everything, or a red little cross if one of them failed. And then you know immediately, all right, so this little thing failed in my code. I'm going to zoom in right there, and I'm going to fix that little thing. It's probably just 5 lines of code you have to parse in your head. And that's a real benefit. And look at the time. It's 64 milliseconds to verify my code. Everything. Now, this is a very small example, so of course other tests is going to take more time, but it's still undescribable what's the name? Improvement of what we had before. So the speed is one benefit, and it's actually the first one I want to go through. Since it takes me 64 milliseconds to run those tests, I get immediate feedback on whether my code works or not, and I can dive straight back in and keep coding all the time. I never pop the browser. I never wait for anything to boot up or loading debug symbols. Of course, unless I start debugging, but I load way less debug symbols because I'm closer to the code that I'm actually testing. The second thing I want to outline is that you get way better self-esteem. You're confident about your code. You know that your code worked 2 minutes ago. You know that the error you introduced was made in the last 2 minutes. Otherwise, you can code for like half an hour, pop the browser, and you have no idea which line was it that messed up. So you're very confident while working this way. Third thing, one of my favorites, is that you actually bring documentation. If you saw the talk about documentation earlier today, one of the last slides was actually introducing tests here. And some magic thing you can do with some of the software that generates documentation is to link your tests to different parts of your documentation. And what is the sole thing that we usually go to when we look at documentation? You go through kind of the overview of the software, and here's how you're supposed to be using it, and this is the blah, 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 blah. At least, for my part, I scroll to the first code example and look at that one. How do I use this software? And that is what unit tests bring you. It's actually all those small examples, and you can link those back to the documentation. And for my part, if I check out a new library on GitHub, for example, I usually just go to the tests and look for the most logical tests to get started with and see how they use their software. Finally, there's the big point of refactoring. When Martin Fowler wrote the book Refactoring, he explicitly told us that we should have something verifying our code every time we did a refactoring step. If you don't have tests verifying, as Corey Haynes said on Twitter once, refactoring with tests is just moving shit around, because you have no idea whether you actually changed behavior by that refactoring or whether it's still the same. You might have introduced some inconspicuous bug by doing that, but if all your code base is covered with tests, you'll notice immediately. And you can refactor, run your tests, refactor, run your tests, and you can change your architecture completely and still be completely confident that your code still works. And that is only possible with tests. Another good question is, what's a unit? Martin Fowler again says that a unit is whatever your team decides is a unit. There's a notion that a unit has to be a function, that you have to test every function in your software. That's a fallacy in my mind. A class might be better, and we'll get into that on the next slide. But of course, a unit can also be a set of classes. It could even be a web page using several classes. A whole integration piece, it's still a unit test. When you test several applications together, 2 applications might be a unit for that test scenario. So unit testing isn't only about going down to the bottommost detail level of your software and testing everything in isolation. It can be whatever your team decides. The point is you have automated it and you have fast feedback. But let's have a look at the simplest units anyway. The simplest units are functions, getting some pure values in, manipulating them, returning simple values. That's really simple to test. My recently used list is kind of like that. It's more like a class manipulating its own inner state, but it's still something known as POCOs, plain old C# objects. These are the things that are really simple to test. Shove unit tests in there, as many as you wish, to verify that that piece of code actually works as you expect. It's really simple with simple values. But there are some dragons in there to be aware of. Meet these guys. The first one's name is Mr. Assert Too Much. That can be a big problem. And if you have that problem, you might be better off cutting down a bit. Because asserting several things in one test is something that is easy to start doing. You've manipulated some state, and you have several things that actually changed in there. So you go, assert this, assert that, assert this, assert that. But it's actually a breach of the single responsibility principle. Suddenly you're testing several things at once. And the worst thing is, if the first one fails, you'll only have a partial picture of what actually went wrong. Because you won't get the rest of the assertion errors. It's going to crash on the first one. This is actually a bit better in JavaScript, because some of the runners there go past the assertions and just collect everyone. But it's still a lot of code to write. And I want to show you this really cool tool that I use called approval tests. So say I have this test for my recently used list, where I don't have that many asserts, but I have the assert that there are, after adding 11 items, the list should still only have 10 items in it. Should probably not be standing too close to that one. And I can check what the topmost item is, and I can check what the bottommost item is. Of course, I could go through all the items and assert all of them, but using approval tests, you can feed the entire object to one statement. So you just go, all right, verify my class, verify the entire state. And what's going to happen then if you're in Visual Studio and configure it with one attribute, it's going to pop a diff for you. So you can see the entire state of the object, and you see what you got on the left-hand side, and you see what you expect on the right-hand side. And I introduced some silly values there just to show you that it indicates that, oh, 4 and 7 is actually something different than you expect. And you have the whole picture immediately. Now, this is a simple example, but in one of my projects nowadays, I send payment requests to NetAccept. And if some programmer had come along and removed the least common currency conversion there, I would see immediately that, oh, something's wrong. We're going to get 10 times less money now. We have to fix this. And there's also even something wrong with the tax down there, but I have to scroll to see it. But in any case, I've got a complete picture now of what several classes did when they built this payment request and what the state of it is versus what I expect. And that gives me immensely more speed than having an assert for every little property in this thing. That would be killing my speed. So this brings a shitload of value, if you ask me. And it got all of those nice little overloads for assertion. You can assert JSON, my favorite, like we've just seen. HTML is a nice one. PDFs, if you work with that, XML, and you can extend it and add your own things. Verify all is the collection assertion we just saw. So as long as you can serialize your output, you can use approval tests to assert how big graphs you want, as long as you can kind of parse it after and understand what went on there. So that's a really big win. If you start using it, make a big high five you rock to Llewellyn Falco on Twitter. It's the one guy who wrote this. But what happens when we have two classes? Now it starts getting fun. So when we have two or more classes interacting, perhaps across modules, perhaps the one is in Umbraco and the other one is in your code won't work without actually having something from Umbraco or whatever library you're using, or even your own. But you do have two things that now have to work together. When we have that scenario, we call the thing that you're actually testing the system under test, and the other one, or the other ones, the collaborators. And when you do this, this is per definition an integration test. It doesn't have to be a database, but it is actually two different artifacts interacting together. So interaction tests start the minute we start combining classes. If you have something using string builder, you're actually doing an integration test between your code and a string builder. It's a definition. It's not kind of its own thing where you have to have this and that. But it's worth minding that single functions, single classes, are really simple units, really simple to test, but the minute you combine things, you're integration testing. And it's worth bringing with you in the mindset. This also brings a whole set of new problems if we do things like I/O. Databases, a very prolific type of I/O in our programming. Web servers, another prolific thing in our programming. And of course, Umbraco uses all of these. So when we test Umbraco and use artifacts from Umbraco, we're all over this scenario. And this is not POCOs. These aren't plain old simple C# objects. These are complex beasts that need something to tackle them. And that's something that's been introduced in Umbraco 8. I'm pretty sure most of you know what it is now, but we're going to do a couple of slides on it. And it's known as dependency inversion. It's when we remove those I/O, database, web server dependencies to be able to actually do that integration test in some way. So imagine we have this scenario where we have a unit test, and we have our system under test, and we have some collaborator, and that collaborator uses something in IIS. So it does server map path, this and that, gonna blow up. And it goes select this and that from the database. And it won't run, because you don't have IIS and you don't have SQL Server running in your test environment. So what we do then is that we introduce an abstraction for that class with those dependencies. Some interface, some base class, something that don't actually have those details in it. And we implement that in a collaborator or inherit that base class. And what we're able to do that then is to replace that collaborator for our test. So we create a fake collaborator that the test creates and feed to the system under test, instead of having it automatically instantiated in that class. By doing that, we can remove those dependencies for our tests, and we can still see if the system under test actually collaborates well, actually integrates well with its collaborator. When we do this, we use a concept called test doubles. They're usually known as mocks or stubs. There's also a technique called fakes that I'm more and more getting in favor of. We'll see about that later. But by doing this, we replace the collaborating class with dumb objects that are only there to satisfy the data needs for the tests you're running. So you don't have to have the entire setup, you just have to make sure that your tests actually get the data they need. And we can remove all the other dependencies. You can do this by writing a class completely manually. If you have a repository, for instance, that would go to the database, you can make a fake class that have an internal list, and you can just keep the database in memory instead of going to the database every time. And that's fairly easy to set up. You can just feed it a couple of new instances, or the class could even fill itself up with some seed data that you can query. Using stubs and mocks is something we're going to come back to in a little while. All of this takes time as well. You have to add all this code. And there are a lot of dragons involved with that. So meet these two guys again. But this time his name is Mr. Stub Too Much. And of course, whenever you do that, you better cut down a bit. So what happens when you use this technique called stubbing is that you actually have to declare every method call or every property that your code is going to be using, and you have to set up every little result that's going to give you. If you have two, so if you have one, it can be a lot. It can be several lines of code just to make that runtime generated stub responding in a way that you want for your the code you're actually testing. When you have two, it's like n+1 after a while. And it can be completely unmaintainable in the end. It's going to be way more code than the actual act and assert thing that we want in our tests. And the worst part is, when you set up the state of such a class, you might not have caught the exact same behavior that the production code is going to give you. So you might actually be testing the wrong thing. There might be a discrepancy between your stub code and your actual production code. And you won't be able to catch the bugs that you catch in production. That's bad. That's not the intention of testing. Here's an old example of some of my code that do stubbing, and this is to test a few hierarchy things in Umbraco, and it's a page full of things. I've even gone dry and not repeated this part just to set up some content and content types in Umbraco, and then I have to set up the content service to return this and that based on IDs. I could most likely use a dictionary here and cut this code down by like 8 lines. But it's still a whole lot of code to write, and I really, really don't like it. I want to make it better. So as I said, testables might require a lot of extra code. Using fakes might be the better way to go. So don't use those runtime stubbing tools every time. If you have something that you can keep completely dry, make a fake and try to simulate what it would actually do in production instead. If you do have to stub, the most effective way to kind of set up those stubs is if they return larger POCO graphs, because those you can actually serialize. So when you can deserialize something at the start of your tests and just feed that to one stub method, and everything else is going to work, you have several other classes that interact with that set of data, you're going to be way better off. There's going to be one line of stub code. Read it from disk and feed it to my stub. There's also a big misconception that mocks are the only thing we use to fake things. That's a real fallacy towards the two first definitions of this. We've got stubs and we have mocks. And when you have a mock, the only thing that mock should do is to verify some call to that interface. So say the payment request that I showed you earlier is actually fetched from a mock where I go verify that this method was called and then run approval tests on the actual parameter it had. And I can verify that I would actually send that to the remote service, but I stop it at a network line and verify the entire message. That's a mock. Everything else is stubbing when you set up data for your system under test. If you end up doing all this all the time, you might end up hating unit testing. So do mind it, and do try to keep your setup code short, preferably by deserializing data and setting up one method. So what I'm really saying is integrate as far as possible. You wouldn't necessarily want to integrate everything, because that's going to take a long time to run. But try to integrate to the extreme borders before you actually start hitting I/O or volatile dependencies that we don't want to test. One way to do this with Umbraco 7 is to actually go into the Umbraco config file and just fetch all the XML you need for some fancy scenario. And you can feed that to Umbraco's base test library, and then the content cache is already set up. All this is going to be fetched from the content cache now. You can just go content cache get by ID, and you're going to get the site there if you pass it 3. You do have to set up some other things, but in any case, this is way less code to set up the same scenario, and I didn't do any effort to get it. I just copied it out of Umbraco's cache file instead. Pruned it a bit, of course, but it's way better. I'm way more happy when I have this kind of stubbing code, because that long string there could just be in a file instead, and then it's a one-liner. And I can go into the file if I'm curious, but when I'm working with these scenarios, I'm not really that curious. I have set it up well. If you do want, you can go to the database. But if you do, make sure to create a fresh one for every test run. And seed it with just enough data for your tests. Maybe you have some common data that should always be there. Maybe you have some data that you add per test. But if you don't have the same state for every test, your tests are going to break every other day because people shove in different information that shouldn't be there. So you can't use a dev database. You have to make some way to create your database every time. Incidentally, this is really easy with Entity Framework, so I do recommend you have a look at how that can be done. It takes a couple of seconds, but then your tests are ready to run. Another thing that is really cool to do when we use Umbraco, and we do have the content cache, is to use a tool called Razor Generator. What it does is that it, on design time, generates the code that would otherwise be generated by CSC/exe when you start up the web server, but it's already pre-compiled and it's classes in your project. So you can render your views without actually having a web server. And if you combine this with approval tests, then you can go verify HTML, instantiate the view, render it with whatever model you've built up before you do this final get my result thing, and you'll get a diff between the HTML you expect and the HTML that you actually got. Sorry, I'll go back since people were taking pictures. Cool. Finally, I want to do, not quite finally, but I want to go through a bit about acceptance tests, which is kind of the level above integration tests again. Because NUnit isn't the only framework out there to build cool and good tests. There is a product called Cucumber that has this language called Gherkin, where you can actually write your tests in plain English. You can write it in Norwegian. You can write it in Danish, German. They've got language providers for everything. And the thing that you have to mind is these 4 keywords. Everything after those keywords are plain English that you invent. You use a tool called Cucumber, and that tool is going to parse regular expressions that it finds in your tests and see if it can find sentences that match those regular expressions or a new pattern language there. And if you've made your regular expression right, it's actually going to extract this little piece in quotes here and pass as a parameter to your tests. So you kind of build up a small domain-specific language to test your system with. For our purposes, you have to look for a tool called SpecFlow, because that's what the .NET port is named. And there's a tool you can add to Visual Studio to get syntax highlighting and a few file templates. It also generates NUnit tests behind the scenes, so you still use NUnit to run this. If you properly layer this, you can use the same specifications that you have in clear text to run your domain code. You can switch a little configuration piece, and it uses dependency injection, so you can start injecting actual integrated database calls instead. And if you're really daring, you could abstract your whole test suite and inject something that uses Selenium and goes through the whole stack. And you can flip this configuration bit so that you can run those tests really, really fast against your domain code, against the database, or on a build server, maybe overnight. It can run for hours doing everything through the GUI. And you'll have a full report the next day whether your complete suite of classes still work correct on a web server with preferably a seeded database. If you want to get into this and also more on unit testing, I really recommend you convince your boss to buy some videos from Cucumber School. It's 200 euros, but it's 3-4 hours of really high quality content to get into this kind of testing and the whole process that comes with it, known as behavior-driven development. They're also going to show you this test pyramid that says a bit about how much time you should spend on every type of test. And the original test pyramid says that you should have a lot of unit tests covering most of your code base without any integration, so you can kind of zoom into every little feature when something breaks. You should have quite a few integration tests and then a few acceptance tests on top. Several people misunderstand this when they start to do acceptance testing, and they make a lot of acceptance tests through Selenium and through the GUI and with the database and everything, and that always takes time if you don't layer it properly. And there's kind of the same amount of integration tests and no unit tests. That's never going to give you the speed benefit you want. So do go back to this pyramid format. But most of us are consultants. And again, time is an issue if you have shorter projects. If you have a long-lived project that you're going to maintain for years, do the whole stack up front. It's going to save you a lot of time in the long run. But if you have kind of a shorter project that ain't going to have the same lifetime, and maybe the customer is going to leave you immediately when he's got the product, then my preference is actually to stay in the middle there and test as many things as possible together with as few tests as possible to kind of flesh out all the scenarios. But my favorite is when I can give it kind of that XML content or JSON content now with 8, shove it through a whole pipeline of things that happens, and then get the view rendered at the end and verify that one. And that's a fair bit of integration. It doesn't do the whole stack, but it does enough that I'm fairly confident that Umbraco will do the rest, and the web server will do the rest, and the browser will do the rest. So then I tend to ignore the fact that you should have that fat layer of unit tests on the bottom, because that will take time, even though it gives you way more confidence. But as consultants, I say that we are allowed to stay in the middle here and make something to work fast with. Couple of short statements on legacy software. A lot of us have software that doesn't already have tests. What do we do then? Should we throw it away and start over? I would rather start by adding tests for every new feature I make from now on. That might be hard though, because things aren't loosely coupled. So the trick then is to find those things that you have to integrate with, and if they don't have any abstraction, use ReSharper, use Visual Studio's refactoring tools, and extract an interface so you can add that fake for your new classes, even though that's going to be pretty hard for your old classes. This is known as seams. So you introduce seams where you can inject some fakes into your code. If a lot of the code is private or protected or internal, so it's hard to call it, go ahead and publicize it. Unless you're making a public API with a lot of consumers. If it's mostly you actually consuming this code, it's way better to have somewhere to call that code in your tests than not being able to test it. That's a fair trade-off between encapsulation and testability. I would prefer testability any day. And if you're really struggling with this, there's a great book describing everything you need to know to introduce seams into old bad code called Working Effectively Within Legacy Code by Michael Feathers. Brilliant guy on this stuff. It's the authority book. All right, enough. Let's see a bit about Umbraco and how we can use Umbraco well. First of all, exploit the core tests. Umbraco have written like 3,000 tests and a whole suite of things that stub up and set up Umbraco for testing that we can reuse. There are still some internal things in Umbraco that we can't use, but when we use that test library, a lot of the things are already stubbed up, so we can just access it through interfaces, but Umbraco has taken care of all that heavy lifting that we don't want to do. It's available as a community build by Christian Tillemann. I'm not sure if he's here. Oop. Give him a high five as well on Twitter. When you get that, you have like 20 base classes, different base classes that you can inherit in your own tests and just build upon whatever they did. I also recommend looking at their tests to get a grip on how things actually work in there. But if you still have to call internals, you can add another assembly to your solution called Umbraco Unit Testing Adapter. And in Umbraco Core, there's an internals visible to attribute that exposes everything internal to this assembly, so we can use it and then import our public classes in that assembly to our tests. That can also require quite a lot of code, though. So I think I have this nice little... I don't. Well, so what I did was that I created a class called Umbraco support. It doesn't have any NuGet package, but it's on GitHub, and I recommend that you copy it into that unit testing adapter assembly, because it wraps up all of the stuff that you would otherwise use. It inherits one of those base test classes. That means you don't have to. And as I said, it stubs up pretty much everything you want to do. So in our tests, preferably in setup, we can go, the link is coming in a minute, so I would wait with the pictures. I'm also going to share this presentation. I'm pretty sure it's going to be on the Codegarden site. So you just go setup Umbraco, and you can start using a lot of the features in Umbraco. A lot of those services, though, are stubs, so you will have to set up the results for them. But it's going to be way easier, and again, with deserializing some content, it's going to be way quicker. And I've written several examples with this class, and you can find them on that URL. That will show you pretty much how you set up typed content with the published content service, how you can work with the database. That might be bugged, actually, but all the samples are there. Go look at it, and you'll find most of the features that you want to use in Umbraco in your tests. And I find this a way better method, like kind of using a new instance of some support class than actually inheriting the things in Umbraco. Because that, by inheriting Umbraco, you suddenly block your own ability to create a test hierarchy. And you can make more of these classes and just compose them. So you could have a database support thing that might be integrated or not. You can have an external service support thing that have stubs for your external services. And you can keep your stubbing in those reusable classes instead of repeating it in every other test. How are we on time, by the way? 10 minutes? All right. So yeah, that gives you kind of an interface for your tests. Imagine those classes are kind of a UI for robots testing your system. They need something else than us humans, but you can help your own tests a lot if you kind of centralize all that code in there and integrate as far as possible. So what about Umbraco 8 then? We now have dependency inversion everywhere. Everything is injected, everything is abstracted. Brilliant. Everything can be stubbed. And we can do that in our adapter assembly. But that's going to take a whole lot of time, again, and I don't like that. So, what really happened, which is also kind of weird, but it's going in the right direction. But what we really did was just swap these two. And we're off, right? But there is the problem of new cache and internals. So everything that new cache does is based on internals. So we either have to go into our unit testing adapter project and make public fakes of all these things, so replicate all that code, or we can use, we can call our test project that, but I do have some plans for this Umbraco support thing. The base classes are still there, but things are shifted around. And we can actually use the same process that we did for 7, using that XML stuff to stub up the content cache, but we don't have anywhere to copy that from. And there might still be a lot of places where current are used, so you can't actually inject stubs to things. That's a repeating, so I'm not going to do that again. But we need kind of new test APIs in Umbraco 8 now, since everything has been shifted around. And my hopes and prayers is that we get more like Umbraco support now for Umbraco 8, but it's going to take some time. I really want to invite you all to come and join the discussion. It's already a PR on the main repo, and there might be some RFCs around soon on the same subjects. But we do have several paths to go now, because there are so much new things with the cache, and we already heard that the cache can be replaced and are under consideration. I think new cache is going to live for quite a while, though. There are actually some fakes ready in the test project, but of course they are internal. So we'll see about that. But what I really want to do is get back to that kind of same XML thing that we had, because there are real classes in there, internal, and we do have a plan to make those public. I have been discussing this a lot with the core team, and the current plan, the proposal is to publicize everything in Umbraco. The reason Umbraco doesn't publicize everything is that they reserve the right to break compatibility, right? And we don't like breaking changes. But a lot of the things in Umbraco are constantly modified and constantly tweaked to get the performance better, the architecture better, and then it's better that the core team keeps those things internal so we don't have to upgrade every little minor that comes around. But the proposal is that they use an attribute instead and use the new Roslyn compiler to throw errors if we call what would elsewise be internal methods. With a twist, we can add an attribute to our assembly instead of Umbraco having to go internals visible to everyone. And by adding that kind of assembly level attribute, we accept an end user agreement that we are prepared to handle breaking changes and accept that, and we only do it in our tests project so that our production code doesn't break, of course. That's going to be a way better scenario, and it's going to give us access to all the internals that we want to stub up at the right level so we can integration test as far as possible. And I think that's a good idea, and I do hope we can get there already this summer for 8. Because I do think that published content, the stuff that comes out of the cache, should be at the forefront of our testing. That's pretty much what we handle, what we work with every day with Umbraco, is content, so we need an effective way to get that. There is a pull request. I do welcome any help I can get with that. So I invite you to let us find the sweet spot between integration and stubbing so that we can be as fast as possible when we do our testing on complex sites. With that, do we have time for a few questions? 5. All right. Any questions? Anthony.
Is that on? So you said you want Umbraco to publicize everything. Do you actually mean everything, or just enough things for you to do tests?
Good question. I wouldn't necessarily say publicize everything, no. Should probably moderate that. But yeah, everything that we need to test published content should be public so that it is easy to set up published content in your tests.
Okay. And can you verify whether or not you were raised in some sort of a unit testing monastery?
That's classified. That's internal. Good one.
More questions?
I'm going to be here all night, so come find me if you want to talk more about this concept. And do come help out on GitHub and the RFCs.
Thank you so much.
Thank you.